generally in functional safety, we want to say it's safe because we've analysed everything, we've understood everything. And for SOTIF, we've now, for the first time, we actually need to embrace, we're arguing about uncertainty. We can only say we've reduced the uncertainty to a level that is considered acceptable. Yeah. Exactly, yeah.
Hello, and welcome to Ingenuity, the podcast series from HORIBA MIRA, where we go behind the scenes of next-generation vehicle development. In each episode, I'm joined by a technical expert in their field as we explore some of the mastery that lies behind the magic. I'm thrilled today to be joined by Edith Holland. Hi, Edith. Welcome.
Hello. Hi, Sarah.
So, Edith, you're Chief Engineer for Functional Safety here at HORIBA MIRA. Can you introduce yourself, tell us a little bit about that role, but also how you got here? What's your career journey?
Thank you, Sarah. Yes, I've been with HORIBA MIRA coming up for 6 years now. As you said, I'm a chief engineer in the functional safety team here at HORIBA MIRA. So I look after functional safety projects, customer projects. I help in business development, trying to get the customers to understand what their needs are. I do a bit of functional safety training and also get involved hands-on on the project sometimes. As well as functional safety, another area I look after here at HORIBA MIRA is SOTIF. That's why we're here talking about it today. How did I get into SOTIF? I started my career at Jaguar Cars at the time after studying electrical and electronic engineering. And I've always worked in the area in an area that's related to safety. I started off with safety validation testing, actually here at MIRA. So I was quite familiar with the proving ground even before I actually joined the company. And that's really got me interested. So I got to drive Jaguar Cars around the proving ground, which is something that you can impress your student friends with when you've just joined the company soon after graduation.
Yeah, definitely not a bad job to have, is it?
Exactly. That moved on to doing safety analysis work, and I had the opportunity to work in lots of different areas at Jaguar, starting off in powertrain, moving to chassis electronics, electrical engineering, and finally ADAS, and that's where the topic of SOTIF first came about. And I then had the opportunity as well to join the ISO working group, the ISO working group that's both responsible for ISO 26262 and the now existing SOTIF standard.
Brilliant. So it's great. You've had such a kind of variety, as you say, of kind of different areas, and being able to bring that all together and from a safety perspective. I know we'll probably touch on that a little bit more in a minute. But you mentioned SOTIF, and we did a 4-part podcast series with David Ward, who on functional safety and its history. And obviously, he touched very briefly on SOTIF, but we knew we wanted to have this conversation with you. Can you tell us a little bit more about it? So, safety of the intended function, kind of what's its origins, how did it come about, and also why do we need it?
Yes, of course. So, David talked about the history of ISO 26262. It's been about for some time now, and with the development of the first edition, if we include that, it's been 2 decades now. At the time, it was practical to have a very limited scope for what safety meant or what ISO 26262 covered. It was the scope of the malfunctioning behaviour. But with these ADAS features that I mentioned, that we're now quite familiar with in vehicles already, lane keep assist, ACC stop and go functionality, or even more advanced systems that are coming in now, it was found that there was another type of fault that we need to consider. So these systems could cause hazardous behaviour without the traditional limited definition that we had in ISO 26262, the malfunctioning behaviour, where things had to go wrong, where something had to break. But an ADAS system that misinterpreted its environment could equally cause hazardous behaviour. A braking system that brakes for no apparent reason because it misinterprets some property, maybe a reflection on the road.
What's happening in the world around it.
Exactly. And that's where SOTIF picked up basically the gap. So I don't know if we've mentioned it already. It stands for Safety of the Intended Functionality. If that is not familiar to any of the listeners, it was felt that it was necessary to give engineers additional guidance to address hazards caused by the functionality. It's slightly different in other industries as well. So I've spoken to safety engineers in other industries, and they sometimes get a bit confused. Why have you got ISO 26262 and SOTIF? That's because in other industries, they are more rolled up together already. Yeah, so safety engineers in other industries might find it a bit strange, but the distinction is that SOTIF covers hazardous behaviour caused by just the functionality, and the aim is to give people guidance how to analyse the functionality in a systematic way, and then also perform verification and validation that gets you to a point where you can put an argument forward. I've done an amount of effort that I think is appropriate to consider this is a safe system.
So there's an element in there of kind of risk assessment. Is that kind of part of SOTIF?
Yes. Overall, it follows an approach that again is common in safety engineering everywhere. ISO 26262 has got a risk assessment, and people familiar with the standard will know the risk assessment uses severity, exposure, controllability to determine the ASIL of a hazardous event, and that then leads you into what needs to be done afterwards. SOTIF has a similar process. It's slightly different though, insofar that it's not using the ASIL scheme that we are very familiar with as functional safety engineers in the automotive industry. And that makes it, I suppose I would say, a little bit harder. We're still arguing about severity and controllability of hazardous events. But without the ASIL, the standard actually has a step where risk acceptance criteria need to be set. And that's something the industry is still sort of grappling with and getting to terms with. And
is that why, so you were saying other industries, safety engineers in other industries tend to roll 26262 and SOTIF together. Is that why automotive tends to split it out? Because actually there is a progression there. There is a sort of journey, I guess, towards how you assess safety and all the parameters that go around that for vehicle technologies.
Yes. So in, for example, IEC 61508, where the system model behind what's being analysed is a little bit different, but the approach there is that once you've identified hazards, you address the hazard. You look at risk mitigation by defining safety functional requirement and safety integrity requirements. So the safety functional requirements are more about what does it need to do to make this safe. And then the safety integrity argument is more about how well does it have to do that? How robust does it have to be against faults? And that's what we are wrapping. That's what's wrapped up in IEC 61508 in the same process. Whereas in ISO 26262, we are splitting the integrity out, and with SOTIF we're covering the safety functional requirements. I would say the reason is that, I suppose originally, functionality in the vehicle, or what was considered safe functionality, was probably more understood, better understood for the traditional systems, like braking systems, steering systems, or you had regulations. What does lighting need to provide? It was well known. So the focus on the functional requirements was really only, it was only found an issue when the ADAS systems came about, because you're now suddenly taking over functionality that the driver used to do, and how well did the driver do that?
Yes. I guess the responsibility changes then, doesn't it?
Exactly.
And therefore the responsibility of the safety element of that changes. I did a podcast recently with Michael Orgill, where we talked about, again, touched on SOTIF, but we were talking about autonomous vehicles and Project Harlander at Belfast Harbour. And again, I think he talked about the safety assurance case, which I think SOTIF kind of is a fundamental part of, but there's sort of a wider piece around that, isn't there?
Absolutely, yes. So the outcome of running a SOTIF process is that you would put forward a SOTIF argument saying that the intended functionality is safe, and that is certainly, as you say correctly, a key part of the safety case, the assurance case that you would put forwards. Yes, and the functional safety team and the SOTIF engineers within our team and the CAF team work closely together and have worked on a number of projects, because their expertise, as Michael was talking about, is very much about the probability, the stochastics that you because you're arguing about uncertainty in the end. That was the big shift for us from functional safety. Generally in functional safety we want to say it's safe because we've analysed everything, we've understood everything, we've confirmed everything, and we can say this is now acceptable, this is safe. And for SOTIF, we've now, for the first time, we actually need to embrace, we're arguing about uncertainty. We can only say we've reduced the uncertainty to a level that is considered acceptable. Exactly, yeah.
It's fascinating. I find this, incredibly interesting, as you said, that kind of step into uncertainty, unknowns. How do you assess the kind of safety and robustness of systems like that? It's absolutely fascinating. And I think David Ward as well talked about this kind of safety of safety culture. And I know we were chatting before, and you kind of referenced that kind of multiple environment for safety decision making, particularly with new trends like the software-defined vehicle, for example.
Yes, no, absolutely. I think sometimes safety can be seen as I suppose, almost the spoil sport in a project, because we might be the people who say, no, you can't do this, or something isn't good enough, it's not acceptable. And there are some trends in the automotive industry. I mean, machine learning, for example, would not, software algorithms containing machine learning would not have been acceptable in safety-related software systems not so long ago. But it's understood now that this technology is needed in order to provide some of the functionality people want. So instead, methods have to be improved, adapted. New methods for safety engineering need to be found, and SOTIF exactly is one of the ones, having a new standard that supports new features that are being developed. And as you said, software-defined vehicle is another area where possibly slightly less related directly to SOTIF, because it's the type of functionality that SOTIF applies to, not so much the how it's implemented, if it's in a software-defined vehicle. Although very often the more advanced features would most likely be implemented in a vehicle that is based on a software-defined architecture. But we've got some other challenges in general safety engineering. Then there are more iterations, changes are introduced more often, and keeping track of what you've analysed and where your safety case is the other challenge we've got. Then how can we adapt our safety engineering methods to keep on top of, to keep up with possible changes that are happening more regularly in a software-defined vehicle.
Very interesting. And I mean, we're talking a little bit here about the future and kind of what's coming and some of the challenges. What is the future for SOTIF? What's sort of happening there?
Although the standard, I suppose we could say, is already on its second version, because the ISO 21448 was initially published as a publicly available specification because it was felt industry was looking for guidance, and it's a way of getting this guidance out quicker in the format, in the structure of how ISO is working. It's now a full standard that was published directly after the PAS, but it's still, I would say, at the moment quite objective, with areas that are not as well defined and structured, I would say, probably as ISO 26262. That's obviously had a lot more time to mature. So next steps for me, I think, are it will get updated with guidance that is adapted to how industry has changed. So also how the ways of working, the processes, the methods in this area have changed, but also bring ISO 26262 and SOTIF closer together. I know David talked about that in one of his podcasts as well, that there are actually camps that would like to see both standards more aligned, maybe a little bit more, like I said, in IEC 61548. It seems that that's not going to happen. I think people in the automotive industry are generally still more happy keeping them separate.
Yeah. Do you think that's because it's a sort of second layer, I guess, or another lens, or a...
I think there are different reasons for different people, different organisations. Sometimes I think it's how organisations have set themselves up.
Right.
Of course, there are automotive organisations that don't work in the ADAS space and feel it's not applicable to them. Having a reference that they can ignore is easier than having a reference that they need to unpick what applies to me and what doesn't.
What are your thoughts? Do you think it's better separate? Do you think actually that gives people greater clarity?
I think I'm a bit on the fence, I have to say. It's because as an organisation like HORIBA MIRA, we have to work in the way the customer is working. So we would adapt anyway. Yeah. So we can. So we can work either way.
I guess from a HORIBA MIRA perspective, we can bring it together.
Yes,
or we can keep it separate, whatever is needed from that perspective. So
absolutely, yes.
And I guess, like you said, you're on the fence because I imagine there's advantages and disadvantages to both. Yeah. So, watch this space. It'll be interesting to see what happens.
Yes, the update will happen more aligned with edition 3 of ISO 26262, and the intention is exactly that, to put sufficient links in to make them work together more easily for those organisations that do want to embrace both.
So can you tell us about any common misconceptions with SOTIF? Are there any things that people believe that you might want to address today?
Yes, there are. So I talked a little bit about people wanting to keep ISO 26262 and 21448 separate, and some people trying to combine the two standards more. There are actually also different camps, or I suppose maybe discussions ongoing, more aiming at, do we actually need SOTIF? Is it not already covered in ISO 26262? And that's due to, I suppose, a little bit interpretation as well. In ISO 26262, as I'd said earlier, we've actually got the scope restricted to that we are only concerned about malfunctioning behaviour. So we're looking at failures and faults, and particularly random faults and systematic faults. In ISO 21448, I said it's not about malfunctioning behaviour. We're looking at making the intended functionality safe enough. And the causes that we're looking at there really are causes that lie within the functionality. The functionality reacts incorrectly in an unintended way to something happening, and the something happening is external to the vehicle normally. So we're talking these ADAS features that are looking at objects in front of the car and reacting like to lane markings to leading vehicles. And we talk about insufficiencies, functional insufficiencies is the terminology used in the SOTIF standard. And yeah, exactly. The question sometimes isn't functional insufficiency not just a particular set of systematic faults? And I suppose, yes, when I explain it in training courses, I deliver the SOTIF training course that HORIBA MIRA has got. The way I try and explain it to people is the systematic fault is something where something goes wrong in the design when I'm translating from one level of requirement into the next level down, when I go into more detail into my design. Whereas the functional insufficiency is more about interpreting a requirement that deals with what's outside the vehicle. So it is a bit of a nuance, and in that respect, I suppose it's something that people are struggling with a little bit.
So I guess it's in that kind of data processing of what's happening outside and how those decisions are being made. That's really interesting, and I think it has challenges as well, though, doesn't it? I think SOTIF in terms of how it addresses some of these areas.
Yes, in general, functional safety engineers that are familiar with ISO 26262, I suppose, have by now got used to the very structured way that it's setting out its requirement and what is expected to be done at certain stages, what that would look like and how it all fits together. It's using the V life cycle model, and it's a nice one activity follows another. The challenge with ISO 21448 is that it's not as neat and organised at all. The activities described are very iterative, so you're going around activities again and again, really with the intention of optimising the system towards safety. How you build that into an engineering process is a challenge, because it's a lot more difficult as well to estimate how long an activity will take, whether you're actually at a stage that you're happy with after an iteration, or whether it requires another one or another one. So yes, that's something organisations are struggling with, how to embed it. But even the actual activities themselves are a lot more open. They're formulated as objectives, so you should achieve an objective. How you go about doing that is left for an organisation to decide. So unlike ISO 26262, where we've got more more mature methods, I suppose. And that's what I was hinting at in the next edition of 21448. New methods might be coming in as people have discovered new ways of working. And then I think the final challenge I'd probably mention is coming back to the uncertainty as well that I'd mentioned earlier. So we're not like in ISO 26262 where we are expecting to a point where we say, yes, we've gone through all the activities, we've done the analysis, we've specified safety requirements, we've confirmed that the safety requirements have been implemented correctly, we've verified, done verification, we've done validation, we've documented it in a safety case. We think we're here, this is good to go. Yeah, I said with SOTIF, we get to a point where we say we have done enough, that we have now convinced ourselves we've got the evidence at this stage that we've reduced the uncertainty and that we've confirmed the behaviour is as expected in all the scenarios that we understood. We think it's good to go, but we're going to keep an eye on it, is basically the next step. So we will monitor how the functionality behaves in the field. That's something that was introduced in the full edition of ISO 21448. So when it moved from the PAS to the full standard, the field monitoring requirement was introduced. You have to have a process in place that allows you to have information coming back, and additionally have a process that allows you to react updates in some way, or even stop the functionality operating in the field. And in that respect, it is a lot closer to cybersecurity, of course, as well, because they are operating in a changing threat landscape as well. Just because at the point where you release the vehicle, you think you've got all your cybersecurity measures in place that are good enough, doesn't mean that there'll be new threats developing over time that you might need to adapt and react to. And in that respect, SOTIF and cybersecurity are more aligned in the overall towards making vehicles resilient and robust and safe.
And I guess that's that point, isn't it, for their whole of their life cycle, like
as long
that
as
whole journey that they're on. I mean, that's absolutely fascinating. I think what's really interesting about HORIBA MIRA is that grouping of vehicle resilience, as you said. So you've got functional safety, you've got your experience around SOTIF, you've got cybersecurity, and obviously electromagnetic compatibility as well, in that kind of suite of ensuring that a vehicle is resilient throughout its life cycle. So I've got a final question for you, Edith. You, as you mentioned, you do a lot of training of kind of new SOTIF engineers of the future. Can you tell us what your advice would be to the next generation? How can they kind of get into this type of role, and why should they?
I've found functional safety a discipline that allowed me to move around a lot and see lots of different areas. As I said when I introduced myself, in Jaguar Land Rover, I had the opportunity to work in lots of different departments because functional safety is a skill set that you can port across and apply on lots of different systems. So if that's something you're interested as a young engineer, you don't just want to get stuck on working on the same thing again and again. Functional safety is a good skill set that allows you to do to move around. What I've found as well, both at Jaguar and Jaguar Land Rover and here, it's often an engineering discipline that attracts a lot of female engineers. I don't know if there's something about making cars safer that
it's very purpose driven.
Yes,
isn't it?
So it's been nice as well to work in environments that maybe are a bit more balanced from that point of view. And maybe finally, the other thing I would say is because particularly when you're working on new technologies or new features, new functionality, where safety is often one of the considerations. So you often get to work on the new things rather than maybe more the run-of-the-mill activities. So, yeah, to any new engineers, you do need a good grounding in engineering. So do whatever you're interested in. Be it electrical, electronic, software engineering. I mean, we've although ISO 26262 and 21448 are predominantly concerned with EE systems in vehicles. We've had mechanical engineers, we've had aeronautical engineers, because in the end you still need to understand how the vehicle behaves. So what happens if your suspension system fails in that way? Is it going to go this way or that way? The mechanics help you in that way as well. So the actual engineering discipline is less of a concern, but it opens a lot of doors. You can, at HORIBA MIRA, we work with lots of different organisations. That's something I've found particularly rewarding here. So yeah, I would recommend it.
Yeah, definitely. I mean, hearing you speak, as you say, purpose-driven, variety of a role, working on very new technologies. But I think also in itself, what you've been explaining about that kind of evolution of mindset as well, from that kind of very regulatory, we've done the thing, we can tick the box, to actually we're moving to a world where there's so much uncertainty and it's that continual journey. That's been genuinely absolutely fascinating chatting to you, Edith. Thank you very much for joining us today.
Thank you.